Hey y'all, this is a video about how to do an ambiguous case problem using the law of sines. And I want you to remember that it is the law of sines still. It is just different given information. The law of sines questions that we did earlier were problems where you were given two angles in a side, but this time we're given two sides and a non-included angle. It's still law of sines, but the way you approach it has to be a little differently because it could be one that has more than one solution. So let's go ahead and figure out how many solutions this problem will have. It is a case one problem. If you look at it according to the angle is less than 90 degrees. So we know it's a case one. If it's a case one triangle, then we look at that dark gray area on your chart and you compare the side lengths, A and B. Just so happens that 30 and 34 are those side lengths, and 30 is less than B. All right, so A is less than B, so that puts us in the top row of the chart. If you're in the top row of the chart, what does that mean? You got to look at the test to see how many solutions this thing will have, because we are unsure if it will have 0, 1, or 2. So you take your A value, which is your side length at 30, and you compare that to side B, which is 34, times the sine of the angle we were given, which is 23. In the calculator, you'll do a little figuring over here and find that this is 13.3. 34 times the sine of 23 degrees is 13.3. Now, if we compare that to 30, 30 is greater than that. So that means we're looking for the column in the first row that shows what happens when the value of A is greater than B times the sine of A. Well, that's the very last column on the top row, and that means you're going to have two solutions. All right, now that you know that, what you want to do is actually start working it out. And remember, this is law of sines. So for the first solution, what we're going to do is just draw our triangle, label what we know, and go from there. And I always draw mine in the same way, A, B, C, just like this: A bottom left, B bottom right, angle C at the top. All right, so 23 degrees for A. The side is 30, and the side of B is 34. So if we're going to solve the triangle, that's the whole point of this problem, but we just don't know what's going to happen before we do. So that's why we have to do all this preliminary work to figure out how many solutions we're expecting, and we're expecting two. So when we solve the triangle, we know we need two answers. All right, so what are we missing from here? We're missing the measure of angle B. We are also missing the measure of angle C and side C, and that's right down here. So those are the three things that we've got to find for this first solution. Okay, now when we're using the law of sines, remember it's A over sine A, B over sine B, and then C over sine C. And the sides are on the top, the angles are on the bottom. In this triangle, I'm only given the side A, angle A, and side B. So I've got to start with these first two ratios in order to find angle B. Let's plug in what we know. And then 34 goes on top here. And I do not know the value of angle B, so we're going to leave that big B there. All right, now we're going to do a little cross multiplying. 34 times the sine of 23 is equal to 30 times the sine of big B. Trying to isolate B, but it is attached to a sine, so we need to leave it that way. Alrighty. So I do want to bring my calculator on screen here and show you a little trick for this part. All right. So what we have is a fraction on the left, and we're trying to calculate the value of the angle B. So when you get to this point, what I would do is enter in the fraction you have. 34 times the sine of 23 That's divided by 30. Now, when you hit enter, you're going to get a number that doesn't make much sense for an angle. And it's because you aren't finished, right? We're trying to figure out what angle has a sine value of this. So we're going to do second sine, inverse sine, and we want to do it of the answer. So if you'll hit second and then this little negative button down here where it says A and S, that plugs in all those decimals for you. Turns out that this angle is 26.3 degrees. So angle B is 26.3 degrees. All right. So over here in our missing information, we can write that it is 26.3. And then I want you to think about what you've got in this triangle. Okay, if this is 26.3, the next thing we need to know is the value of angle C. So if you will add your angles together and subtract that from 180, you will have angle C. So 180, excuse me, that is added together, minus what happens when I add 23 and 26.3 together gives me 130.7. That's a big angle. 130.7 degrees. So that's angle C. All right, if we know all of these things, then we are only one missing piece short of finding everything out about this triangle and solving it. So we're going to find side C last here, and we're going to use another law of sines ratio to do that. I would use the original information we were given of 30 and the sine of 23 degrees, that was our A ratio, and set that equal to side C, which we do not know, over the sine of this big angle, which is 130.7. We'll cross multiply. Divide. Okay, now this one will not require us to use an inverse sine. The reason why is because we are finding a side length. We are not finding an angle. So when we enter this into the calculator, it will tell us what we want to know, and we will be finished. It will be something that looks reasonable. All right. Try that one more time here. So if you do put that in the calculator and something doesn't make sense about your answer, make sure you've put in everything that you need to put in. I just tried it and I didn't put in the sign in front of the number 23 and I got a really weird answer. Okay, so I knew something was off. So side C is 58.2. Now remember, you can go back and double check the reasonableness of your answer by thinking of this biggest angle is across from the biggest side. The smallest angle is across from the smallest side, and that does hold true, so I feel good about that answer. All right, but that's only part of it, right? We know we have two solutions. So what is happening on this triangle is side A is short enough so that we could manipulate it and actually form a triangle if we placed it this way here too. It would also make a triangle. So I'm just going to draw this picture again and try to do a little bit better job. So if here's angle A, all right, and if side A, which is 30, when we just regularly set it up, if I were to move it back this way, it would still form a triangle using the side length 30, the angle of 23, and the side length of 34 for B. So there's another triangle there. We've got to solve for this triangle here on the left. So that's what I'm going to do. I'm just going to draw that one. So what if it was this triangle instead of the big one? Because it's still using the same information. And that's what makes this tough, is that you may not exactly understand what you're doing, but that's what you're doing. You know, when we initially draw this triangle, we're solving from the one that most people would write out initially anyway. Most people aren't going to try to make this small triangle. So when we do one of these questions, every time you are solving the big triangle, and I'm going to ask you to solve the smaller one second, because that's usually the way most people will approach it without even me saying anything. Okay, because that's what we find first when we do our ratios anyway. So All right, we got that figured out. Now, on our original one, we said the big triangle that it was 26.3 for angle B. Well, we talked about it on an activity one day was that when you swing this other side inside, you are forming a little isosceles triangle. That makes this angle also a 26.3. Well, what does that have to do with anything? Well, if these two angles are congruent, then I can find what this angle is, and that's the one I want to know anyway if I were to do this smaller triangle. Well, how are they related? These two angles are supplementary. And if these two angles are supplementary, well, these are also because, well, these two angles are the same. So to find the measure of angle B for your second solution, it is fairly simple if you understand that relationship. Angle B for solution 2 is going to be 180 minus the angle B you had for your first solution. Why? Because they're supplementary based on what we just said. So 180 minus 26.3 is 153.7. Wow. That is a tiny angle. Okay. It's a very, very tiny angle for C is what it's going to end up being, is what I was saying. All right, so if angle B is 153.7, then angle C is going to be quite tiny. It is going to be 3.3 degrees, and that's okay. It's very tiny. It's still making a triangle, but it's just a really, really small side and an angle here for this remaining piece. All right, so we've got angle B, we've got angle C. Now it's time to find side C. How do we do that? Little law of size proportion. All right, so let's use the same information we did on the other one as our given. So a side 30 over the sine of angle 23. We're trying to find side C. So we're going to use the sine of 153.7 down here. Do a little cross multiplying. Make sure that you bring the sine down with your angle. If you don't, you will not get an answer that makes much sense. All right, so let's see. Sine 23 on the bottom. I am getting 34.01, but that does not make much sense, does it? Let's see where I have made a mistake. Okay, I'm back. I figured out what I messed up on. Did y'all? You probably figured it out while I was doing the work, and that's okay. All right, so sometimes even the teacher messes up, right? Okay, so where did I mess up? I'm trying to find side C. I used angle B instead of angle C. So here should be a 3.3. I knew something wasn't right. Okay, so Miss Brown's got to start this one over again. All right, ready? So we need 30 over the sine of 23. I'm trying to find C. So if I'm trying to find side C, I got to use the sine of angle C. There we go. Now I'm getting it right. Now let's do a little cross multiplying. I knew I was supposed to get an answer that was very tiny, but I was getting one that was not the right number. Actually, I had just saw for what I already knew that it was 34. Anyway, all right. Try again here. Okay, I'm getting 4.4. That sounds more reasonable. Okay, so 4.4 for that side. Now, actually, this question, I have it pulled up. Let's double check our answers and make sure we are right. And it looks like we are. Okay, so that's good. All right, do you see how I wrote my solutions out to where they're easily labeled? And if somebody was looking at my work, they would know where to find them. So please make sure that you're labeling yours similarly. And I hope this helps. Sorry about the mistake, but it's good for you to see that even I mess up and I still have to figure out where I went wrong. I hope you have a good day.